Today we will start with the chiller calculation. Okay, there are two type of chiller. One is air cooled chiller, another one is water cooled chiller. Okay, so basically this is the syllabus structure, and also if you go to my folder, you will get all the folder structure like architecture, space planning, codes and standard, chiller calculation, cooling tower, chilled water pump head calculation, expansion tank, sizing, air and dirt separator, chilled water pipe and its accessories, and chilled water chemical treatment system. Okay, so basically this is the complete uh, network. Okay, as for the chilled water system. Okay, so when I go to the
Mhm.
cooling tower calculation, okay, you have a lot of documents inside, and if you go through one of the document uh, for the chiller calculation, if I go to the chip calculations, so you will find one Excel sheet, okay, called chiller load calculation, right?
Mhm.
Okay, so this chiller load calculation is basically what? Say, basically it's the heat from the building, right? You're going to
Yes.
find out what is the total heat inside the building, so that you can cool that building, right? So how
Mhm.
you find out the building heat based on the HAP calculations, right? For each and every space, based on the requirement, uh, based on the floor area, ceiling, lighting load, electrical equipment, then people, then envelope, okay, like you like wall, glass, okay, floor, roof, partitions, everything. Based on that, you are going to find out what is the heat inside the space. It's like each and every space. Okay, so based on that, you are going to feed all the data into the particular Excel sheet, and you are going to find out what is the total. Based on the system output, you are going to find out what is the total heat inside the building, right? So for example, if I calculate all the heat, okay, as a total, say for
Mm.
example, I am going to find out for this particular projector, there will be 2694 kilowatt, right?
Yes.
Okay,
Yes.
so this is my total heat. So I know the total projector, what is the cooling requirement, right? Okay, now I'm going
Yes.
to select the chiller, right? Say for example, if I want to select the chiller, there are procedures, right? For example, when you do the chiller selections,
Mhm.
there is a step. Okay, there are important points to be considered for the chiller selections. Okay, so this is what we are going to discuss. Right now, you are going to
Okay.
calculate the chiller capacity. So how you design the chiller capacity based on the heat, what you calculated based on the each and every spaces, like by means of hub calculation, right? Okay, now
Yes.
you are going to
Yes.
approach the chiller manufacturer to select the proper chiller for that particular building, right? Okay,
Mm. Mm.
if you go through my chilled water introduction, like the chilled water basic chilled water system, you will find out what are the type of air cooled chiller, what are the systems, like what are the components inside the air cooled chiller, right? Like you have a compressor, you have a evaporator, condenser, then you
Mm.
have expansion valve, right? So these are the components
Yes.
you might
Yes.
have based on that you might have seen. Okay, now when you go to the chiller manufacturer, right, so he have a different models, right?
Mhm.
Okay, so for that particular project, say for example, you require say for example 2700 kilowatt, right? We will make it round off. Assume that for just for the calculation purpose, I will just make it 2800 kilowatt as a round off, right? Just for
Okay.
understanding purpose.
Yeah.
Okay. Now, if you approach the chiller manufacturer, okay, they have a various capacities, right? Say for example, as a starting from, I will tell you that 200 kilowatt.
Mhm.
Okay. Okay, there is a 200 kilowatt. Okay, then you have a 400 kilowatt. Okay, then you have a 600
Mm.
kilowatt. You have a range assumed like that, right?
Yeah. Yeah. Yeah.
Okay, so when you say this particular range, okay, available from the manufacturer, this is based on the certain ambient conditions, right? Say for example, normally whenever you go to the chiller manufacturer, he will do the testing based on the AHRA condition. That is one of the important point.
Yes.
Okay,
Which is the
so
T1 conditions.
the
Yes.
capacity is arrived based on the AHRA condition, which means that the
Yes.
chiller is tested based on 35 degrees Celsius. Okay, so when you
35 degrees Celsius.
yeah, when you export that chiller to the different countries, it will vary country to country, depends upon that ambient temperature, right? Say for example,
Mm.
as I said last time, you have a 200 kilowatt. Okay, so this particular 200 kilowatt is based on 35-degree temperature, right?
Mm. Yeah.
Okay, now when you bring that same chiller to the UAE, right? Say for example, you have a 46 degrees Celsius, right?
Yes.
So when you
Yes.
bring it to 46 degrees Celsius, then your kilowatt will vary, right? Say for
Yes.
example, when you, say for example, uh, this is the 46 degrees Celsius, right? So the 200 kilowatt for 35, and when you say 46 degrees Celsius, assume that the kilowatt will be approximate like 150 kilowatt or 140 kilowatt.
150, or yeah, it will
There is
reduce. It will reduce because of the higher temperature.
because of the ambient temperature. Okay. Similarly, when you bring when you export the same chiller to the some other country where you have a less than 35 degrees Celsius. Okay. Say for example, yeah, you can say that the capacity will be increases. But one more thing you just note it down. Okay, when you say that why they normally they test at 35 degrees Celsius, that is also one of the reason. Okay. So when you go less than 35 degrees Celsius, you may not require chiller, right? Maybe you can go with a normal. You can say that. You call that adiabatic cooling, right?
Mm-hmm.
You heard about adiabatic
chiller, yeah?
Yeah, adiabatic chiller, or adiabatic chiller, or like you can say that what you say free cooling. It's a free cooling chiller, or there is a evaporating system, right? Evaporatic cooling system. Okay, so based on you have also some other options. Okay, when you go less than 35 degrees Celsius. So that is also one of the important reason that why they test the chiller at 35 degrees Celsius, right? So the more than you go, you need a cooling. Okay, but the lesser you may not require a chiller. You may require some other type of systems, which you can say adiabatic cooler. Okay, like something kind of things. Okay, so that is one of the important point to be noticed. Okay, now say for example, assume that we are doing for the project in Middle East. Okay, you have a 46 degrees Celsius. Okay, so you are going to select the chiller capacity, right? Assume that based on this condition, your chiller capacity may be 140 or 150 kilowatt based on the ambient conditions. Okay, now so your availability will be based on this temperatures, right? Okay, now assume that you have a different capacity based on this temperature. So now whatever you calculate the heat load, you are going to divide the capacity of the chiller for that particular project. Okay, assume that after duration, okay, just for our assumption purpose, we will say that this is the kilowatt for the 46 degrees Celsius, right? Okay. Now, say for example, I have a 2,800 kilowatt in my project. Okay. Now, what I can do, even if you go to the manufacturer, you have a 1,200, you have 1,400. Okay, he have a 1,600, right? And say for example, he have a 1,800, and he have a 2,000, and he may have a 2,200. This is for the comfort cooling. Okay. When you go for different cooling, maybe it will be like a different type of supply temperature, inlet temperature, or outlet temperature. You have a different,
say like high temperature chillers.
Yeah, high temperature chiller, or you have a different delta T. Okay. If you go, if you speak to the manufacturer, they have a different range. Okay. Some temperature, some chiller will operate at say for example 7-12 degrees Celsius. Some chiller may operate at 10-15 or 10-20 or 15-25, something. They have a different range. Okay, so as a comfort cooling, we require normally the temperature will be, say for example, like 7 degree will be the chiller out, and the 12 will be the chiller in. Okay, so that is one of the requirement. Okay. Now I'm going to select the number of chillers. Basically, you have arrived the chiller capacity. Okay, you are going to calculate the chiller capacity, right? How you calculate the chiller capacity depends upon the total. Okay, and also the number of working chiller. So say for example, I'll be going to as per my project requirement, I make based on the dimension, right? So I may able to fit like 1,000 kilowatt chiller, right?
Yeah.
Okay, depends upon the length of depends upon the space, right? Say for example, if you see space constraint, okay, the length of the chiller you have to see based on the project space availability, right? Maybe I cannot install 1,600 kilowatt chiller because the space not available. Okay, so that is one of the factor, right? And based on that, I have decided now 2,800. I will go with the 1,000 kilowatt chiller. Okay, so what I can do, I can go with the 2,800 is my total capacity, and the chiller capacity will be 1,000. So I'm going to 3 number of chillers, right?
Yeah.
So this is the way I'm going to select the number of chillers, right? Okay, I will come back to you the assist chiller later, and then you have a standby chiller. So normally whenever you do the chiller system, you will do based on n+1 system, right? Because there is a duty and also standby. So normally you will go with the one number of chiller will be standby, right?
Yeah, but that one number of standby, you've gone for 1,400 then 1,200. Any reason why? Because
no, this is 1,000. kilowatt 3. No, I'm not going with this one. See, don't see this one. I'm just seeing that
Okay.
3000, three numbers of 1000 chiller, 1000 kilowatt chiller, and one number of
Okay.
1000 kilowatt chiller.
Okay. Understood. Understood.
Yeah, clear, right? Okay, so you normally go with the 4 number of chiller. Assume that still I have a space constraint. Okay,
Okay.
I cannot go with the 1000 kilowatt chiller. Then you may have to go with the 800 chiller, depends upon the space requirement. Or I can go with the 1200 kilowatt chiller because I have a enough space, right? Then what I can do, I can go with the 1200 into 3. So it will come
Yes.
like, or it will, if you go with the 1200, it will come like 2400. So you have to go to the one more chiller, 1200 into 3, which will be very high, right? So the
Yes.
actual chiller, you can go like a 1000 kilowatt when you have a load of 2800 kilowatt, right? So this is the way you can calculate the chiller capacity, number of working chiller, and then the number of standby chiller based on the space constraint. Okay.
Okay. Can
Okay.
I ask you one question if that's okay?
Yeah, you can ask. Yes.
Yeah. So in the chiller capacity, this is I know you're trying to say the chiller capacity if this is at 100% load, right? But this
Yeah.
100% load is not always the scenario though, right?
Yeah, but you have to select for 100 percentage, right? So you will be having a scenario that where you have 100 percentage, right?
Yeah.
So that time your
Uh,
chiller should support for 1000 for the 100 percentage requirement. Okay. Also, you
okay. So
can
no
plan one
matter.
more. Also, you can plan one more. The way of selecting the number of chillers. Okay.
Mhm.
You can also choose in different scenario. See, when you select the number of chillers or number the capacity. Okay. Say for example, assume that I have a one building. Okay, and it will not be operating for 100 percentage all the time. Okay, like I have a 70 percentage, I have a 80 percentage operations.
Yeah.
Okay,
Yeah.
so that time you will apply diversity factor. That is called diversity.
Mm-mm.
Okay,
So
even
that
though
will
you,
be okay. That is
yeah,
coming down in the steps. Okay. No. I wanted
even,
to clear that because
yeah,
this I have seen it in more like residential or hospitality sort of purposes rather than
yeah,
mission critical buildings. So it's different. I understand. No.
yeah,
Please,
but
please
it
carry on.
depends on the building to building. Say for example, if we talk about residential, okay, you know that the occupancy level will be you can say 60% or 70 percentage during the peak time, right? If you talk
Yeah.
about any of the residential project, most of the people will be out for the work, right?
Mm-hmm.
Okay, and they will be it may be 100 percentage occupied during the night time, but when you see that ambient temperature, it will be lesser temperature. So you don't really
Yes.
require to go with the full capacity. So there you apply diversity
Mm-hmm.
factor, right?
Yeah. This is
So
what I wanted to understand.
instead of
I know
2000,
you will be discussing this down the line, so I just thought
yeah,
I'll
instead
just.
of 2800, maybe I will apply zero point 0.7. Okay, so you may go with the project capacity of 1960 instead of 2800 after applying diversity. So now when you do the chiller selections, you can do chiller selection based on this particular capacity, right? So say for example, I have a
Yeah.
1960. Okay, so what I will do, I will go with only 2 chiller instead of 3 chiller. So here I am saving the cost, right?
Understood. Yeah.
So this is the diversity here. You can say that. I think that also we have discussed that day. Okay, now
Mm-hmm.
one more thing, you're going to calculate the water flow rate, right? So the water flow rate is basically required for the pipe sizing or for the distribution. Okay, what is the water flow rate is
Mm-hmm.
required to cool the particular project, right? It's required.
Yeah. Yeah.
Okay, so that also we will discuss. We have equation. Okay, then after that we have a chiller coefficient of performance. Okay, you are going to calculate the cooling kilowatt divided by electrical kilowatt. So that is give you the coefficient of performance which is required for the authority. Okay, so how much of power you will consume to generate certain kilowatt of cooling load, right?
Mm-hmm.
Okay, so that is also given in the COP. Say if you go to local regulation in the Middle East, you will find out normally 2.8. Okay, as a minimum. Okay, so
Yeah.
it may vary depends upon the country to country authority, but in the Middle East, most of the countries like 2.8 will be the standard. Okay, and also you will
Mm-hmm.
calculate for the compressor. Okay, for the COP, and you will
Mm-hmm.
calculate the chiller efficiency. Okay, then you can calculate the chiller energy efficiency ratio based on different units. Okay, so one you will calculate based on kilowatt, another one will be calculated based on the BTU per hour. Okay, but it is
Mm-hmm.
more or less same, but the value will be different because of the unit. Okay, so if you go to
Yeah.
even authority, you have a two different units. One is a kilowatt, and another one is the BTU per hour. Right.
Yeah.
Okay, and if you go to the chiller seasonal energy efficiency ratio, you can call it as a
Mm-hmm.
IPLV value. Okay, so that is done based on HRA condition, which is 35 degrees Celsius. Okay, and also you have a seasonal energy efficiency ratio or NPLV standard. Okay, NPLV value, which is based on local condition. Say, for example, if you are in India, 40 degrees Celsius, so you will do the chiller performance based on 40 degrees Celsius. Okay, if you are in Middle East, you will do the chiller performance based on 46 degrees Celsius. Okay, to find out how much energy you are consuming. Okay, during the pot load scenario. Okay, the pot load will be basically like 100 percentage, 75 percentage, 50 percentage, and 25 percentage. Okay,
Mm-hmm.
that is a chiller percentage, chiller operation, and also
Yeah,
your chiller.
but in
Yeah,
this case here, do we have to calculate for each individual like integrated part load condition when we are giving it to for approval or anything, or is it generally?
no, when you say IPLV value, it is for the complete system, right? For the chiller.
Yes, yes, yes. Okay,
So when
okay.
you do the chiller, it will be there. The IPLV value will be there in the chiller
Will
selection
be
itself.
there. Okay, okay.
So whenever you
It's
speak
not
with the
necessary
chiller,
that we have to calculate it though, right?
no, it's not required to calculate, but we just know how to
We need to
calculate
understand what
because
the concept is and how to
yeah,
calculate it.
yeah.
Understand?
So when you approach the chiller manufacturer selection sheet, it is already mentioned. Okay, so when it comes for approval, you have to verify that what is the value. Okay, say for example why that IPLV is different. Okay, the matter. Okay, or the COP is matter. Say for example when you go with the different manufacturer have a different technology, different refrigerant they use. Okay, they have a different efficiency, right? Okay, so some manufacturer can give you 3 COP, some manufacturer can give you 3.5, some manufacturer can give you 4. Okay, so that means
Mm.
if somebody is using 4, that means they are most efficient chiller, right?
Yes.
So that is one of the factor. Okay, but when you go always there are two scenario. Okay, when you go with a lesser performance, that means your price will be cheaper. When you go with the higher performance, your price will be very high. So that is also one of the concern. Okay, so some
Yeah,
manufacturer,
yeah.
some client, what they do, they go with the low efficient chiller. Okay, what they will do, they will they will pay lesser price, and also they will just check what is operation cost during the year, right? So they will try to balance that operation cost and the chiller pricing. You understand, right? What I mean?
Yeah, yeah. Can you hear me? Yeah.
Yeah, yeah, I can hear you. No, what I'm saying, when you say there are different type of chillers having a different COP, but the client will decide. Okay, he can
We'll
decide
decide
depends
which
upon
one
the.
does it need to go at the end of the day because of the
Yeah,
cost
there is
and
a price.
other.
Yeah, there is a cost also. Sometimes they cannot put an initial cost, but whereas they can uh, try to
They're okay
balance
with the
during the operation.
maintenance or operation
Yeah, during the
costs.
operation they can try to balance it. Okay, so that is one of
Hmm,
the
hmm,
one of the
hmm,
important point. Okay, then the ambient
hmm,
temperature is
hmm.
very much concerned because as I told you, when you go with 35 degrees Celsius, you have a different capacity. When you go with
46 degrees.
46, you have a different capacity. Okay, so
Yeah,
that is
yeah.
one of the important parameter. Then you have a chilled water in and out. Temperature is very much important because the chilled
Hmm,
water
hmm.
in and out should be in line with what is your indoor, right?
Yes.
So when you do the calculation for the HAP, you have to consider certain input chilled water in and out value.
Yes.
Okay, so
So
that
this is one
value.
thing I wanted to understand as well, because generally in your say from my experience where I've done fit outs, and fit outs you already know what is the chill water temperatures in and out. So you
Yeah,
aren't
because
really
how you
have any
know? No,
procedure.
how you know? Because what is your chiller is designed for that, right?
Yeah, exactly,
So
exactly.
based on
But
that, you
if
will select your indoor unit for the fit out.
mm,
You can
yes,
there is no
yes,
other option that
yes,
you can change the temperature for the fit out when you do the selection
mm,
of the FCU. But when you do the complete
yes.
project, you may have to
Mm,
select either chiller or indoor unit. You have to play in both of the case. Okay, but
both the
most of the
cases.
time your chiller will be take precedence. Okay, because normally
Mm,
the chiller manufacturer will tell you that what is the temperature. Okay, so if you go
mm,
with
mm, mm.
most of the manufacturer like whatever the chiller manufacturer, they also have the indoor unit equipments, right? Say for example,
Yeah.
if you go with the Daikin, they have a chiller and also they have the indoor unit, so they can match
Mm,
what is the temperature for both the unit, right?
yes, yes.
Okay, if you go with a Carrier, yes, they have a both. Okay, if you go with
Mm-hmm,
LG, they have a both. Okay, so something like that, right?
mm, mm, mm. Got
Okay,
it,
but
got it. Yeah.
always the chiller based on the chiller selection, we used to select the indoor unit as well. That is one of the important parameter. Okay,
But
then
finally,
the
my
condenser.
question is.
Yeah, yeah.
Mhm. But my question is now, when you do your HAP initially, you wouldn't, you would have to, at that point, how would you actually add your chill? I mean, the temperatures that you're adding, because at that point, you do, for example, in the concept stage, I know it's like rule of thumb or something like that. Yes, watts per meter square calcs that you do. But still, in this point, how do you actually say, okay, these are the chill loaded temperatures that we're going to arrive at, or, how do we come across those
Uh,
values? There's just one thing I
See,
wanted to
basically,
understand.
the standard temperature from the manufacturer, right?
But then that is just that is only when we approach for a selection and when we get the selection in itself,
No,
right?
no, it's not like that. It is a standard for the stand. See, if you go to say, for example, I will tell you one of the calculate one of the selections. Okay,
Yeah.
I will open one of the equipment manufacturer selection sheet.
Sure.
See, basically, this is one of the manufacturer. Okay, you can see like this is what from the Daikin. Okay, so if you go
Yeah.
down, okay, say for example, you know the chiller standard chiller for the comfort cooling.
Hmm.
Okay, so if I go down for the chiller selections, yeah, this is the air cooled chiller, right?
Yes.
Okay, so if you see this particular air cooled chiller, you can see the temperature cooling capacity is based on 46 degrees Celsius ambient temperature and water in and out 7/12 degrees Celsius, right?
Yeah. Got it.
So this
Got
is
it.
the
Yeah. Yeah.
standard temperature for the comfort cooling. Okay, when you select the chiller, but when you go with the
Hmm.
district cooling provider, you have a different temperatures based on their design.
Temperatures. Yeah.
Okay,
There is a yes.
so we know the standard when we know that what chiller we are going to select, right? So this is a standard for the comfort
Hmm.
cooling, basically 7/12 degrees
Yeah.
Celsius. So based on that,
Yeah.
you do the selections. Like delta T will be like a 5. Okay, sometime you have this also. It may slightly vary depends upon the manufacturer, but we will fix it for our learning purpose. We will fix it like 7/12 degrees Celsius, right?
And 12 degrees. Yeah.
So
Yeah.
based on that, you do the heat load calculation. So when you do the heat load calculation, whatever your capacity will arrive based on 7/12. Okay, so your
Hmm.
chiller
Hmm.
temperature also will be in the same, right?
Yeah.
Okay, so if you go to the this one, you have a chilled water in and out temperature. Then you have a
Yeah.
condenser water in and out temperature. Sorry, in and out.
Hmm.
What is the condenser?
Hmm.
Yeah, yeah. This is for the water chiller.
Water cooled
Okay,
chiller.
yeah,
The
water cooled
condenser
chiller
water.
in
Yeah.
and out. Okay, then
Yeah.
you are going to
Hmm.
select the refrigerant. What is the type of refrigerants? Okay, so there are different type of
Okay.
refrigerants available in the market. One, if you go to this particular manufacturer itself, one R134A. Okay,
Hmm.
sometime if you
Hmm.
go with the R123Z or R123 4ZE. Okay, and
Hmm.
I think R510 refrigerant is there. There are different type of refrigerants. Okay, so that
Yeah.
refrigerant, how you select, one is the efficiency. There are different type of refrigerant give you different efficiency of the chiller. Okay, also
Hmm.
you will talk about low like the ODP and the GWP, remember, which is for lead requirement.
Yeah. Yeah.
Okay, so you will comply that one. So based on that, you will select which
You
is the
mean
best chiller.
when you mean ODP, it's ozone depletion rate, and
Yeah.
the GWP is the global warming potential, if I'm not wrong,
Yes,
right?
yes, correct, correct. Yeah,
Got
yeah,
it.
yeah.
Yeah, yeah, yeah.
So that is one of the important parameters when you do this when you do the chiller selections. Okay, and the diversity factor I told you that say for example depends upon the occupancy. Okay, during the
Hmm.
peak time. Okay, say for example maybe that is not applicable when you go for commercial building. For example, okay, I'm telling you some
Mm.
scenario case to case. If you go to office building, okay, your most of the office will be loaded during the peak time, right?
Yes.
not in the night. Okay, so when you talk about residential, your peak,
Basically 8 to 6 or
yeah,
9 to 5
yeah.
or
When you
eight
talk
to
about
six.
residential, your the more occupant load will be during the night, right, compared to the day. So, but during the night, you don't have a peak time. You
No.
understand, right? So the temperature,
Yes.
so
Yes.
depends upon that, you can play with your diversity factor. Okay, so the diversity factor normally it is all assumption based. Okay, there is no nowhere saying that you have to take for this building this much diversity, for this building this much diversity. No, it's not like that. You have to analyze,
Okay.
properly analyze
Mhm,
the building, how they operate.
mhm,
Based on that, you can apply
mhm.
diversity. Okay,
So
sometimes some
in
consultant,
this case,
yeah, so,
I wanted to understand,
yeah.
in this case here, for example, if I'm using HAP, I mean, I know there is the profile catalog that you use, but have you used the profile catalog anytime? Like,
See,
the.
profile catalog you can use it normally, okay, but it is
Mhm.
not required, okay,
Okay.
because say for example, whenever you select the chiller, always it is based on 100 percentage. Okay, that is one of the factor.
Okay.
You
Mhm,
can apply a profile when you are sure about that. Okay, say for example, when I talk about residential, okay, I will apply
mhm,
the lighting load. I will apply say for example equipment load. Okay, I will apply occupancy
mhm.
based on the profile. Okay, I can do that, it's not a problem. You will get
Yeah.
some
Yeah.
savings. Okay, but that should be very carefully analyzed. Okay, when you enter the
It
data,
can
if
go
you,
either way as well, but most
yeah,
of the
if you,
time, even for residential, you would still take the 100% load, but you would still maybe add a diversity as, like, after carefully analyzing what's the worst case scenario based on experience and everything, and then you
yeah,
basically
based on,
bring
yes,
in your
yes.
diversified chiller values.
Yeah. Say for example, you can also discuss with your the building owner. Okay, how the building will be operated, or the client. Okay,
Mhm,
they will tell you that
mhm,
during the residential, say for example, 60 percentage people will be out. Only 40 percentage will be in home. Okay, so you can apply some diversity. Based on that, you can decide, right? So based on that, you
yeah,
can so the same diversity you can apply in the profile, right? That is a profile.
mm,
Actually speaking, when you talk about diversity, it is nothing but your profile basically. So
yeah,
that will give
yeah,
you
yeah.
the smallest chiller. Okay, when you do the selections.
Got
Okay,
it.
I think yeah. After you apply the proper profile, you may not require to apply diversity because you already applied diversity, right, in the profile,
Mm, mm.
right? When the lighting will be
Yes, yes.
operated, when the human, how the human will be during that time to time, and what is the equipment load will be during the time to time. Everything is based on that, right? And also, I think
Yeah,
last time I told you that there is one more point which is very important. It's called elevation, right?
yeah.
So elevation also very important when you do the chiller selections. Okay, because this elevation also will vary your capacity, chiller capacity, right?
Mm-hmm.
Say for example, because of your the temperature, the air density. Okay, if you go to the normal like a sea level, okay, what will happen? You have a air density will be normal. Like you can say that
Yeah.
it will be at proper sea level density at sea level. Okay, so it can
Mm-hmm.
cool at proper at certain temperatures. Assume like that. Okay, so when you go
Okay.
to higher
Mm-hmm.
elevation, then your the density of the air will be very lesser. So you require either higher airflow or you require the duration of the chiller. Okay, you understand, right?
Mm. Can you repeat it once again if you don't
Now,
mind?
what I'm saying, when you go with a higher elevation, you may require uh, uh, higher airflow rate to cool the chiller heat, or you may have to go for deration.
Okay.
Clear, right?
But then this is only the case when your height is because of the height increasing, your density decreasing, right?
Sorry, sorry, say again.
No, what you mean to say was with the altitudes increasing, say at a higher altitude, what happens is the density of the air decreases, correct?
Yeah,
Or
decreases.
increases?
Yes, decreases. So
Decreases, right? Yeah.
when your density decreases, that means it cannot
Hmm.
cool more heat, right?
Yeah.
It
Yeah.
cannot
Yeah.
dissipate more heat. So that is what is happening. You need either more airflow rate to cool that particular capacity, or your capacity of the chiller will be reduced.
Yeah.
So that is the one of the important factor, right?
Hmm.
Okay, sorry, I
Yeah.
cannot able to. I have to just close this Excel sheet and I have to open again.
Sure, sure. No worries.
Okay, you got the concept right, like for the silver selection. Okay, I will add one more point, which is elevation. Clear? So this is the important 20 points to be considered when you do the proper chiller selection.
Hi, Parni, can you hear me?
Yes, yeah, yeah. What happened?
I think
Suddenly
you're
got
on mute.
disconnected, or yeah, you can able to see. You can able to see now.
Yeah, I can see your screen now, and I am able to hear. I can also hear you as well. I
Yeah,
think it's
yeah,
smooth
yeah,
now.
yeah. Okay, so now this is
Can
one of the
you?
point
Are you
which is,
recording already, or
yeah, it's already recording.
cool, cool? No problem,
Yes,
no
yes,
problem.
the
Please
same. I
carry
didn't
on.
disconnect actually speaking. Okay.
Ah, okay, okay.
Yeah. So this is the 20 point when you do the proper chiller selection. You're clear, right? You're very
Mm-hmm.
much clear.
Yes,
Okay. Then they
yes,
talk about
yes.
maintenance. They talk about operation, space constraint. Okay. Say for example, if one of the chiller selections. Okay. Um,
Mm-hmm.
if you go to any manufacturer and if you ask for the chiller manufacturer, you will get one of the manufacturers from train. You will get, as I told you last time, there is air cooled chiller, the compressor capacity. Okay. Then if you talk
Yep.
about 35 degrees Celsius ambient temperature, fluid entering temperature, leaving temperature. Say for example, this is based on the one of the chiller manufacturer. They give you 5.5 and 12.2. Whereas if you go to the Daikin, they give 5 and 12, right?
Mm-hmm.
So this
Mm-hmm.
slightly vary depends upon the manufacturer, and you have a evaporator fluid type is a water. Okay, then you have elevation, which is very important, 0. This also you have to properly select, because you have when you are working for a global, okay, you have a different countries. When you do the project, different country have a different elevations that you can find
Yep.
out based on the ASHRAE Meteo software, right? The website.
The
If you go
elevation.
to that
Yes,
website, you
yes,
can go to that particular location. You can able to find out what is the elevation. Okay, then the gross
yes, yes.
capacity. This gross capacity very important. This gross capacity is based on 35 degrees Celsius. Okay,
Mm-hmm.
so when you go with a 46 degrees Celsius or based on the local condition, you have to really see what is a kilowatt. So that kilowatt is only your project capacity. This is not the project capacity, right?
Mm-hmm. Mm-hmm.
Okay, and then you have a EER which is 3.31. Okay, so this 3 EER you have to match with your local regulations, what they require. If you go to Middle East local regulation, as I said, 2.8. So it should be minimum 2.8. Some of the time they do the manufacturing. Okay, depends upon some
Mm-hmm.
capacity, depends upon some refrigerant. they may not able to achieve 2.8. Sometimes they see 2.6. Okay, so that
Mm-hmm.
chiller
Mm-hmm.
should not come to the site, or it will be rejected by authority. Okay, so this is one of the important factor. Then the design flow rate. This is the same equation. Remember, we have seen that.
Q is equal to MCP delta T, right?
Yeah, that is one of the equation. And also, if you find out, remember there is a equation when we have seen during our HAP calculations. Okay, also I can open right now.
You mean to say this thing, right? 4.186 into Q is equal to 4.186
Yeah,
MC.
I
Yeah,
have
sorry.
some formula. Maybe you can see here for
Oh,
the
okay,
what.
okay. So yeah, yeah, okay, maybe. Mhm. Okay, this is not QMC. Okay, okay. This is for
Yeah,
chillers, right? I'm sorry, my mistake.
yeah, this for the chiller. I think I can open here this one. HVAC equations. I think hope you have this handbook, right? So if you go
I think
further
you've given
down,
this one. Okay.
yeah, yeah. If you go further down, there is for air and also there is for water.
Mhm.
Yeah, here you can see that equations, right? This for the water side equation. You can see this is for the evaporator and this is for a condenser, right?
Okay,
So
okay.
this is like a when you calculate evaporator flow rate, tons multiplied by 24 divided by delta T. The same equation is applied here as well when you calculate water flow rate.
Okay,
So
okay.
you know what is the yeah, tons, right? Based on the HAP calculation, and based on
Mhm,
the delta
mhm.
T, you know what is the chiller selection you are going to do. So based on that, you can find out your GPM evaporator. So based on this value, you are going to size the pipe sizing for the entire project.
Okay. But then why, what's the difference? Why do we have 24 for the evaporator and 30 for the condenser? I mean, is there any explanation for that?
Yeah, there is one. There is actually there is a equation. See, basically, this is the equation, right? When you
Mm-hmm.
solve the problem, it comes in 1.08. This is unit
Yeah.
conversion. Okay.
Mm-hmm, mm-hmm,
I will give you the proper explanation why it is 24 and 30. Okay. Okay.
mm-hmm,
There is one definition is there. I can tell you.
mm-hmm.
Okay. I will just give you that particular notes. Okay.
Yeah, no worries, no worries. Yeah, yeah. But this is how you basically. But so when we size our pipes, should we size it based on whatever we receive?
No,
That
this is for the building
GPM
side. This is for the building side, and this is
building
for the
side, and
condenser
that is
side.
for the, yeah. So this condenser side is for the water chiller. This is in the case of water chillers, right? If I'm not wrong.
Yeah, water chillers. Yes, yes, yes.
Cool, cool, cool. Okay,
Okay.
okay, okay. Now I
See,
understand. Yeah, yeah.
yeah, I can also tell you why there is a difference. Let me search that value.
Yeah, sure.
Sorry, I can tell you that what is the reason. Okay, there is
No
one
worries. Yeah,
definition
yeah.
is that I'm
Mm-hmm.
not getting. I couldn't able to recall. Okay, I will tell you that reason. Okay, after this class.
Sure, sure. No, no problem.
Okay,
Yeah, we
so
can always
this
discuss it
is so
later.
this is the way to calculate the water flow rate, right?
Sure, sure.
Okay, so you calculate water flow rate based on that. Then your COP of the chiller is basically, if you only go to the selection, you know what is the capacity here, and you know what is the power consumption. Based on that, you can calculate EER, right?
Yeah, yeah.
Okay, and when you go to IPLV value, okay, as I said, IPLV value. If you go the chiller
Uh,
selection, okay,
before that, can I ask you one question here?
yeah, yeah,
Can you go up if you don't mind? That's it.
yes.
I think project conditions. Can you come down, please? Yeah, the unit performance data, the gross capacity and net capacity. How different is it? Because
Uh,
it's just close to each other. That's why I was asking.
See, there are some
How's
losses
that?
actually inside the heater itself. Okay,
Okay, okay.
after these
But
losses, they
we
calculate
calculate using the
net
13252,
capacity.
not
No,
the,
no, we
yeah,
calculate based on the net capacity.
net capacity, right? Okay, okay.
Yeah,
Yeah, yeah.
inside the chiller, there are
So,
some losses. Say, for example, when you go for assume that you are going for AHU, assume like that.
mhm,
Okay, so in
mhm,
the AHU,
mhm.
you calculate your capacity is based on the what you calculated in the HAP, right? For example,
Yeah,
say for
yeah,
example
yeah,
1000
yeah.
kilowatt. But when you say gross capacity, it will be 1000. Say for example 1000 kilowatt is your heat from the building. But okay, but when
Mhm.
you go for the AHU selection, they will give you 1,100. So what is that 100? That 100 is the losses from the equipment. Say for example you have a heat in the motor, okay, and you may have a heat in some other equipments. So that heat
Hmm,
will be
hmm,
added
hmm, hmm.
into the net capacity. So that is why the gross capacity will be higher than the net capacity.
Okay, but we always consider net capacity
Net capacity, yeah, net capacity, because
is
the
what
gross
our values.
capacity is the losses from the chiller. Okay,
Sure. Understood.
right? Actually, you can
Yeah,
say that the gross capacity will be 1326, but there is some losses inside the chiller. After taking the losses, you can say it will be 1325.9.
yeah.
Okay, so this is the net capacity. Based on that, we do the calculations, right? Okay,
Got it. Yes,
yeah.
yes.
Then if you go to one of the selections, okay, as we discussed last time, this is the IPLV value.
But you had a formula, right? That is like 100%
Yeah, yeah, yeah.
into.
So that one, if you go to, as I said last time, okay, yeah. This one basically I took it from one of the manufacturer, okay, or one of the
Mm,
websites, okay, where you can see that chiller load will be 100 percentage, 75 percentage, 50 percentage, and 25 percentage, right? So this is the way to
yeah.
calculate your IPLV formula, right? IPLV equations, okay. So you can say that 1 percentage of 0.01, right? And
Mhm,
you
mhm.
can say 0.42, like 42 percentage of B, and 45 percentage of C, and 0.12, like 12 percentage of D, right?
Mhm, mhm.
Okay, so A is nothing but the COP basically 0%, sorry 100%, 75 percentage, 50 percentage, and 25 percentage. So if I go to one of the chiller selections, okay, you can see here this is the IPLV value, right? And this is the 100 percentage, 25, 75 percentage, 50 percentage, and 25 percentage, where you can see that energy efficiency or COP. You can say the different COP during the pot load, right? The COP,
Yeah.
the COP is very high when you do the pot load. You can also note down one of the points, right? So when you
Mhm,
operate at
mhm.
100 percentage, you get 3.38. But when you go 25 percentage, you have a more savings in the
Yeah.
power, right? Because you get
From an
more power.
efficiency point of view.
Yeah, yeah, yeah. So that is also one of the important factor. Whenever the chiller runs at 75 percentage, you will get more efficiency. And when the chiller runs at 50 percentage, you have a much more efficiency. 25 percentage, you have much more efficiency. So that you can find out based on the COP value. Okay. So when you say that
Mm.
IPLV 5.48, which is nothing but this equation, okay, like 1 percentage of this 3.38, this is the COP, right? Okay, and plus 42 percentage of this one, plus 45 percentage of this one, and 12 percentage of this one. So when you apply in this equation, you will find out 5.48 is the IPLV value, right?
But are we not taking the low, not the net capacity for the formula? Basically, I thought it was capacities, right? No.
No, no, it is not a capacity. See, if you go to this equation, so what is given here?
Sorry.
0.01A. Okay, or I can open one of the.
Yeah, because
Uh,
this
I
A, I kind of got. I thought it
I
was
think
the
yeah,
total
it is
load.
given here as well. It is given here as well. Okay. See, when you say
Okay. Okay.
COP, so what is a COP? Cooling kilowatt divided by electrical kilowatt, right?
Yes. Yes.
Okay. And when you say 100 percentage, 0.01, and 75 percentage, 0.42, 50 percentage, 0.45, 25 percentage, 12 percentage, right? This is the operating load. Okay.
Yes.
Okay.
Yes.
Now, when you say 0.01 multiplied by COP at 100 percentage, you can see here this one.
Okay. Oh,
So the
okay.
COP
Now
at
I've
100
understood.
percentage
Yeah,
plus
yeah, yeah, yeah,
0.42
yeah.
at COP
When
at
the COP
75
is at
percentage.
7.
Yeah. So
Yeah,
this is the way you calculate your IPLV value.
yeah. But these COP values, you have to. The way of calculating this is. I mean, if you say, for example, in the manufacturer selection, these COP values will be there. But do we have to do this manually? Like how to calculate this?
No,
What
no,
will be
no,
the
no.
COP
See,
at?
when you talk about chiller, nothing to do manually, but I am just
Mm.
explaining how you
What are the
calculate.
concepts behind?
Yeah,
Yeah,
concept.
yeah.
See,
No,
for
no, no, no.
example,
Yeah, yeah,
if
yeah.
somebody not given this table, okay,
Mm,
for
mm.
example, okay, so you can able to
Yeah.
calculate, right?
Yeah, that's
COP.
what I'm asking. So that, yeah, that's what I'm asking. So in my case here, if we know the COP is kilowatt of mechanical divided by kilowatt of electric. Yes, but
Yes,
then
yes,
my
yes.
question is now at 100% we know what the load is. That is what is the peak load basically, correct?
That is a peak load. Yeah, and also you
Yeah,
have to
but
request from the manufacturer. Give me 75 percentage, 50 percentage, and 25 percentage.
This is what I'm asking because sometimes, because I kind of got confused because when we take 75% of the load, will it be accurate or not accurate? This is what I wanted to
No,
understand.
this is 70
No, no, I think
percentage
that.
of, see why we take 75 percentage, 50 and 25, because your chiller load, say for example, if you go to this website, what they are saying, operating time, okay, because of
Yeah.
your weather profile, because this is
Hmm,
because of your weather profile, right?
hmm.
Okay, when you get a maximum temperature, say for example 46 degrees Celsius, only that will be for 1 percentage. Assume that 8760 hour. What is 1 percentage? 87 hours. So when you go
It's
to
7 hours. Yeah.
as a overall 88 7 hours or 88 hours only the 100 percentage load. The remaining 42
Yeah.
percentage will be 70 percentage load, and remaining
Hmm,
45
hmm.
percentage will be 50 percentage load, and remaining will be 12 percentage, 25 percentage load. Okay, so that is
Got
the
it.
way
Understood.
you calculate IPLV value. Okay, okay, but if you talk about
But
some, yeah, tell me.
for example, now this IPLV value we've discussed. Now this works. I mean, like, not works. I would say this IPLV value, if we have, like, for example, for a mission critical area, critical building, we take the 100% load, whatever load that is generated as part of your chiller load. Yes, but
Okay,
now
okay.
whereas for residential or any of those loads, for example,
Hmm.
we are taking a diversity in our loads to start off with. Yeah,
No, no, no,
we will
no.
be
So
taking.
we are not discussing about diversity here. We are discussing about weather profile. This is based on the weather profile.
No, no, no. I'm not saying that. What I'm saying is, for example, when you're choosing a selection, for example, in a residential apartment, for example, in HAP we got 2,800 kilowatt, but we
Okay,
don't
okay,
take the exact 2,800 kilowatt for our residential application, right? We will take a
okay.
diversity.
Understand. Yes.
Yeah. And from that diversity further, we will have to check what is our IPLV value, which is at 100%, 75%, 50%, 20%. Correct?
Yeah. After taking diversity,
Yeah. Okay.
see that
All of these steps
diversity.
only.
That
Yeah.
diversity is for what? That is a building load diversity, right? Not for the weather profile.
Yes. Yes. Not for the weather. Okay.
So your diversity is based on the building load, and you're taking
Mm-hmm.
diversity for the diversity for the building load, and you're taking
Mm.
what do you say, the IPLV value, that is for the weather profile.
Yeah. But then this IPLV value is not actually dependent to this diversified chiller load value. It
No,
should
no,
be,
no.
right?
That is what I just now I told you. Diversity factors depends upon the building load. Okay, and
Mm.
this percentage will be based on your weather profile.
Okay. Okay. Mm-hmm.
You can able to match,
Okay.
right?
I think to a certain extent I'll have to maybe go through the recording and
No,
maybe
no, no, no,
go through the
no. One
selection
minute,
once
one minute. I
again.
will tell
But
you again. 1 minute. Say for example, you have
yeah.
a 1,000 kilowatt chiller, right? 1,000 kilowatt load,
Mm,
building load. Okay.
mm,
So this
mm.
building load is calculated based on what? Based on the peak condition, right? Assume that you have
Yes,
a
yes,
1,000 people,
yes.
for assumption. But
Yeah, yeah,
during
yeah.
peak load, when is the peak load of 46 degree? Is it at 3 p.m. right?
Yes.
During 3 p.m., what is the load of the what is the occupancy load in the building, residential building? You can say that 70 percentage, 60 percentage, because people will be out for
Yeah,
work.
yeah.
Okay, so based on that, your peak load, your chiller will really will not run at 100 percentage because there is no
No,
people,
it
right?
will. Yes,
So that is a building load, right?
yes,
So
yes.
why I have to select my chiller for the for the 100 percentage when people is not there? So I will apply diversity, right?
Correct.
So that is based on the building load. Okay, so that is
Yes.
one of the factor. Now another
Yeah.
factor, chiller will not be operating 100% all the time,
No.
because chiller will be operating
Mm,
100% because of the profile of the weather profile also, right? Say for
mm,
example,
mm, mm,
100
mm,
percentage,
mm.
say for example, in during the August month, okay, I request 1000 kilowatt load, building load, right?
Yeah. Yeah.
But when you go to December month, how much load I require? Maybe I need only 70 percentage or 75 percentage, right?
Yes.
Because my
Yes.
outside profile is very low.
Yes.
So that is why you will operate also based on operating time. Okay, so that is the weather profile.
Mm, 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 mm.
So you have to differentiate the building load. That is the based on that you can apply diversity. Sometimes you may not apply diversity. Sometimes you may go with 100
Mm,
percentage.
mm.
Okay, I will tell you
Yeah,
one more
that's
case.
from.
Yeah, I will tell you
Yeah,
one more
because
case
why I
also.
go? Yeah, please, please, yeah, go. Yeah.
Say for example, assuming that there is a hotel building. Okay, hotel.
Mm-hmm.
Okay,
Mm-hmm.
so you know that the tourist the tourism will be peak in December and will be less in August month or June month, right? July, because of the
Yes,
weather
yes,
profile.
yes.
Okay, but
Weather profile. Yeah.
your chiller will be designed for what 100 percentage, right?
Yes, it will be
So, but
designed for
when you
hundred
design 100
percentage, but
percentage,
still
but there is
we
no
will have a
people in
diversity, right?
there is no people in the hotel, so you can apply diversity, right?
Yeah. Yeah. Okay. Yes. Yes. Yes.
Okay, but when you have a peak load during the December month, okay,
Mm, mm.
you can apply your with the diversity, okay. But what is the outside temperature will be very lesser, so it can be
Will be
balanced.
much lesser compared. Yes.
Yeah, it
Yes.
will
Which
be
would
balanced.
balance.
So
Yeah.
that is one of the study, okay.
So yeah, when we do the diversity, also we need to account for all these conditions as well. So okay, what is
Yeah,
the
yeah,
diversity
yeah.
at the worst case
Yes,
scenario? What
yes,
is the
yes.
okay? Mm, 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 mm.
Okay, but when you
This,
go for
but
mission
whatever,
critical,
yeah,
no diversity, zero. Okay, it will be hundred
no, it's
percentage. You cannot take
100%,
diversity. Like when
irrespective
you
of,
go for
yeah, yeah, okay.
when you go for hospital or when you go for server rooms or when you go for any other okay, mission critical, you cannot apply diversity factor.
Got it. Yeah.
Okay,
But then, irrespective of 100, if even irrespective of sizing the chiller to 100% load or diversified load, we will always have to understand what is the IPLV value, which would change based on the weather profile.
yeah, based on the weather profile, yes. Okay, so that is also important because you have to match with authority requirement. Okay,
Hmm,
if
hmm,
you go
hmm,
to one
hmm,
of the
hmm, hmm,
regulations, say
hmm.
for example, I'm talking about this regulation. See, water chiller package, minimum efficiency requirement. So the way you are operating, see, you can operate at any efficiency, right? But why
Yeah.
authority is saying because you are wasting the energy. That is why authority is fixing the value for the selection of the equipments. Okay, so they are saying that 2.8 is the COP you must provide. 3.05 is
Hmm,
the
hmm,
IPLV
hmm.
value you must provide based on
Yeah.
T1 condition. Okay, because this
Got it.
condition, why they are setting this condition? Because people they don't want to waste the energy because they are
Hmm.
manufacturing they're producing the energy, right? Okay,
Yes.
so they will not allow you to waste the energy. You can assume you can consume the energy, but don't waste the energy,
Hmm,
right?
hmm, 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 hmm.
Okay, it is like
Understood.
when
Understood.
you wash your hand, you can wash whatever is required, but don't waste the water.
Yeah.
That is what the code
Understood.
says, right?
Understood. Understood. Yeah. Yeah.
So
Got it.
this is
Yeah.
the same scenario. So now you hope you understand how the selection of the chiller. So this is the way you speak with the manufacturer, right? When you
Hmm,
do the
hmm,
chiller
hmm, hmm,
selections, there is no other.
hmm.
When you have a chiller capacity based on your building load, you can able to decide the number of chillers, okay, and
Yeah.
you can able to
Yeah.
decide the number of chillers, assist chiller. Basically, assist chiller will come in the picture. Say for example, assuming that some scenario, okay, I require assist chiller, okay, when there is a load only, assuming that I will tell you one cases, okay. Say for example,
Yeah.
you remember there is a hotel building, right? In the hotel building you have a
Hmm.
ballrooms, right? You heard about ballrooms
Yes. Yes.
where they do some conduct some meetings, seminar, something like that, right? Okay,
Yeah.
so
Yeah. Yeah. Yeah.
that particular activity will happen very rarely, right? It will not happen
Yeah.
all the time. You don't have a festival all the time, okay? You don't
No.
have a,
No.
meetings all the time, okay? So that
No.
will happen during you expect that it will happen during certain periods, right?
Yes.
Okay,
Yes.
assuming that you have a four ballrooms in the building, assuming that you have a
Hmm,
total
hmm,
project load is 1000 kilowatt, whereas my ballroom load is 300 kilowatt, right? Because it's a very big
hmm,
ballroom, four numbers or
hmm,
five numbers. Okay, so based on
hmm,
your
hmm.
based on your analysis, you are expecting that maybe I have a two ballrooms are occupied in the average
Yeah.
of year, okay, or three ballrooms are occupied, but when it is occupied full, maybe it is in the evening time, not in the daytime, okay. So during the daytime I
Yeah.
have only one ballroom or two ballrooms. So based on that, my analysis, okay, so I can say that I have a load of only 800 kilowatt or 700 kilowatt. So why I have to go for 5 chiller? I can go with 4 chiller. I can add one chiller as a assist chiller. So it will
Mm-hmm.
act as assist chiller whenever there is a load. Otherwise, it will act as a
Mm-hmm.
standby chiller, right?
Okay, okay, okay,
So this
okay,
is the
okay,
way they do
okay, okay,
analysis.
okay.
They do
Mm-hmm.
analysis, then they will do the selection. So
Mm-hmm.
they will say that sometime you heard about when you working with the consultant. I don't want to name it. You can say that they will tell you always. They will say that duty plus assist. You heard about
Mm-hmm.
equipment schedule. They will say duty
Yeah,
plus
in the
assist.
yeah, they say duty plus standby. I
No,
haven't heard duty
yeah,
plus
yeah. Sometimes
assist,
they will
but
say that duty plus
yeah,
assist. What is the meaning of assist? The assist will work
mm.
whenever it is required only. Other time,
Only
otherwise,
when it was.
it will be acting as a standby, right?
Yeah, but then my question here is, so this will change from application to application, right?
Yeah, 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 yeah. Yes, yes.
For example, in your, for example, say any mission critical building, your assist is
No,
basically your
no.
standby
Here,
system.
no. In mission critical, there is no assistance. You have to have a
There's no
N.
assistance.
You have to have a
Yeah,
full N.
yeah, in full N, and then whatever standby is like 1+1. That will
Is
be
a
a
standby.
that will
Is a standby. Yes, is a
standby.
standby.
Whereas
Yeah.
now, if you say for I don't know where else we could put the assist. Say, like you said, the hospital, like in the case of not hospital, in the case of an hotel, like you said. But these ballrooms, how will the chiller understand that okay, the ballroom is occupied and it needs to be further like that the assistant chiller needs to kick in? How does the
No, no,
assistant
that is a
chiller
programming.
understand that?
See, you have an indoor
Okay.
equipment, right? You have an indoor equipment.
Yeah.
So when the indoor
Yeah.
equipment start working, the indoor equipment, how it
Mm.
will start working based on the temperature sensor inside the room, right?
Yes.
So
Yes.
when there is a temperature is hot, when you switch on the AC, your temperature is hot,
Mm.
it will try to cool 24 degrees Celsius. Then your chilled water will be working. PSCV will open and it will be start working, right?
Mm-hmm.
So that time, what will
Mm-hmm.
happen? Your temperature will be high in the chilled water. Okay. So when it goes
Yeah.
12 degree, it may go to like instead of going to 12 degree, it may go to 14 degree or 15 degree. Then your chiller will start to
Mm.
try to cool the water, right?
Cool the water.
So
Yeah.
when it is
Okay.
more
Okay.
cooling is required, then your one more chiller will be start running. So that you have a
Mm.
internal chiller controller where you heard about chiller plant manager.
Oh, I've not heard much about it. Mm.
Okay, it's a chiller plant manager will operate the chiller. Okay, based on the load
Okay.
requirement.
Is it something similar to the BMS or is it like
Yeah,
separate?
it is a BMS. Basically, it is a BMS, but it is one. It is a say BM. You can say that BMS is a different terminology. Okay, when you have a control system
Okay.
for building, you can say that building management system. When you have a
Mm-hmm.
control system for the chiller, it is called chiller plant manager. When you have a chiller, when you
Okay.
have a control system for the lighting, you can say that lighting control system. But it will be similar to the BMS system, but the you can say that the type
But
of
yeah,
controller may
these
change.
are so basically these all come under the BMS. Yeah, if you ask me.
Yeah,
In the
yeah,
wide
yeah,
scheme
yeah.
of things, they all come under the BMS, and BMS is the like the central system, and these are the smaller systems that handle individual elements. So, for example, like you said, chillers would manage the chiller plant manager will manage all of the chiller working and
Yeah,
everything that's
yes,
involved in it,
yes, yeah.
and it is monitored via the BMS. That's how it works. Correct?
Yeah, yeah, you can say like that.
Long
Yes,
story short,
yes. Yeah,
you
building
can
management
sort of
system,
say
when
it
you
like that.
say it is a overall, it's a overall, okay.
Overall picture. It's the overall picture.
It's
Yeah.
overall picture. But when you say chiller management, you have a separate, you have a different type of controller, different type of technology,
Mm-hmm.
and it will operate.
Mm-hmm.
But it will be same like it will operate based on the temperature sensor, based on the return sensor, based on the pressure sensor. It will be like similar to building management system. Building management system also can do that one, okay.
Mm-hmm.
But you have
Can
a
I also
dedicated
ask? Yeah.
system.
Can I
Yeah,
also?
yeah.
Yeah. So can I also ask you one more question? So when you say we have this assist chiller, I know they are all connected to a common header. Like the chiller, all the chillers are lined together, like one next to each other. They'll all have a common header pipe for supply and return,
Okay,
and you will
okay,
have individual like individual pipe from the chiller connected to the
okay,
header pipe, basically.
okay.
So when you say that the assist chiller kicks in means the chill water, I this is my confusion because, for
No, no, no.
example,
See, you
uh,
can see. Say for example, you have a five chiller. Okay.
yeah, yeah,
So the five chiller, it is anyone can be assist chiller or anyone can be standby or
okay, it is
anyone
not
can be duty. It
even
is
though
doesn't mean
okay,
that that chiller is only assisted. Not like that. Okay.
Okay, because when we say 4+1, we intend to say 4 duty and 1 standby. So
Yeah, once
it is
it
up
can
to
be
the chill.
anything can be duty, anything can
Okay,
be
okay.
standby. Okay, that is the way it operates.
Anything.
And also,
Okay, okay,
when
okay.
you talk about the chiller plant manager, it will calculate the runtime hour. Okay,
Hmm.
okay. Say for example, one chiller is run for 6 days. Okay, then what will it will
Okay.
calculate? It have a more running hour. So what will happen? It will try to calculate the running hours for all the chiller, and which is
Hmm.
more running hour have, then that will try to switch off to cool down.
Okay, okay,
So
okay, okay,
there is a
okay.
logic. That is a logic you write, right?
Hmm, 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 hmm. Okay. Yeah, yeah, no, no, no. Yeah, I just want to. Yeah, these are all the bits that I don't have any clue or any idea. So this is
Mm-hmm.
one way of understanding this. Okay, okay. So
Yeah.
essentially, when we say n+1 chiller, that doesn't mean that n has to be the duty every single time. It
No,
could still change
it can be
across
anything.
different time.
Yeah, yeah. It can be anything. It can be anything.
Mm-hmm.
That
So
that
that's
that
why that is
yeah.
one reason why you even size the chiller, even the standby chiller, to the same capacity
Same capacity.
as the duty
Yes.
chiller.
Yes. 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 That is one of the
Got
reasons.
it. Now
Yes.
it makes sense. Now it makes sense. For example, even if it's 2,800 and say we size to 3 and the standby, it would still be 1,000 chiller rather than
Yes.
a
Correct.
lower
Correct.
capacity or a higher capacity chiller.
Yeah. Yeah.
Understood.
Yeah. Clear,
Okay,
right?
okay, okay, okay.
Okay. So
Mm-hmm.
this is the
Clear, clear, clear.
understanding of the chiller, how we do the selection, how we select everything. Okay.
Sure.
In the next class, we will have a small discussion about water cooled chiller as well, because it is the same only. Okay. That is
Mm-hmm,
not
mm-hmm.
a variation, because here it is air cooled, there is a water cooled. Okay.
Yeah,
And there is
yeah,
a
yeah.
separate circuit that we will go through. Then we will go through the chiller cooling tower capacity as well, how to calculate the cooling tower
Sure.
capacity. Okay. Then we will move on. Okay. The chiller is the main part. Okay. So when you know chiller,
Yeah,
you
yeah.
can do anything. Okay. Basically in the chill
Mm-hmm.
water system.
Okay,
Right.
okay. Yeah, yeah,
Yeah.
yeah.
So it's okay. We can have a next session, right?
Yeah, we can have a next session.